Hello, we'll be doing the last part of acid-base salts chapter, laboratory preparation of insoluble salts. This is the concept map shown. First is preparation of ferric chloride or iron 3 chloride. This is done by the direct combination of elements or synthesis. Powdered iron is taken in the combustion tube. The dry chlorine gas is passed through the combustion tube. The air inside the apparatus is expelled, and this dry chlorine gas is made dry by passing through the concentrated sulfuric acid over here. Iron turns red hot since the reaction is exothermic. Now this external heating is suspended. Iron 3 chloride is formed, which volatilizes and condensed in the receiver as a brown scale. Now you can find the reaction. This is iron which is heated. This is the dry chlorine gas. You get FeCl3. Iron chloride is highly deliquescent, so it is kept dry. Using fused calcium chloride or anhydrous calcium chloride is popular drying agent. Anhydrous FeCl3 is used as a catalyst in certain reactions. Now there is a question that why don't we prepare anhydrous FeCl3 by simply heating the hydrated ferric chloride. Now hydrated ferric chloride is FeCl3.6H2O. Because on heating it gives Fe2O3.H2O, Fe2O3 and mono single molecule of water. Okay, so that's why it is not used. So this process of direct combination is used. Second is the preparation of copper 2 sulfate or copper sulfate, popularly known as CuSO4 or blue vitriol. So what is the method? By the action of dilute acid, generally dilute sulfuric acid, on an insoluble base which is copper hydroxide or copper oxide or copper carbonate. The reactions are given over here. Now what you do, you take dilute sulfuric acid in a beaker and heat it on a wire gauge. Then add copper hydroxide or black copper oxide or copper carbonate in small quantities at a time and keep on stirring till no more of it dissolves and the excess compound settles at the bottom. Filter the hot and collect the filtrate in a china dish. Evaporate it by heating to the point of crystallization. Then cool it. You will get the bright color blue crystals of copper 2 sulfate pentahydrate, that is CuSO4.5H2O, and then dry the crystal. This CuSO4.5H2O is popularly known as blue vitriol. Other salts which can be prepared by these same methods are zinc sulfate, lead nitrate, calcium chloride, calcium nitrate and magnesium sulfate. Next is preparation of zinc sulfate. Now zinc sulfate can be prepared by the action of dilute acid, that is dilute H2SO4, on the active metal. The same process you can see over there. Now here the reactions are mentioned. Take dilute sulfuric acid where you will take 1 volume of acid and 5 volume of water. Matlab if you take 1 ml of acid, you will take 5 ml of water to make it dilute sulfuric acid. Now take this dilute sulfuric acid in a beaker and heat it on the wire gauge. Add some granulated zinc. You know this granulated zinc pieces, we have already discussed this one in hydrogen preparation. What is granulated zinc? Little at a time with constant stirring. Then the effervescence will be evolved because of the liberation of hydrogen gas. This you know. Then add zinc till the metal settles at the base of the beaker. When effervescence stops, it indicates that all the acid has been utilized. So you now filter off the excess zinc, collect the solution on a in a china dish, evaporate the solution, you will get the crystal, filter, wash them with water, dry them between the folds of a filter paper. Take a filter paper, put the crystal of the zinc sulfate 7H2O, which is heptahydrate, zinc sulfate heptahydrate, dry them in between the filter paper, and you will get the finally white little shaped crystals of hydrated zinc sulfate, commonly known as white vitriol. Now this iron sulfate or green vitriol is prepared by the same way you have prepared white vitriol. You will get pale green crystals of ferrous sulfate heptahydrate or hydrated ferrous sulfate. Then you proceed for the preparation of lead chloride and calcium carbonate. See this figure? Here the method of preparation is precipitation or double decomposition or double displacement. Insoluble salts can be prepared by mixing the solutions of two appropriate salts, each containing one of its ions. This mixing will result in the formation of an insoluble solid precipitate which will be filtered, washed and dried. Now lead chloride can be prepared by adding either dilute hydrochloric acid or sodium chloride solution to a solution of lead nitrate. So first is either you add sodium chloride solution or dilute hydrochloric acid with lead nitrate, then you filter it, you will get the sodium nitrate solution in the beaker, then take it, evaporate, you will get the lead chloride and then you will get the crystal. The reactions are given. Solution of lead nitrate and sodium chloride will be filtered, then heavy white precipitate of lead chloride will accumulate as residue on the filter paper, then it is washed with cold water and then take it on in the evaporating dish or china dish with some water, then heat it, you will get the pure crystals of lead chloride. So here also you will get pure needle shaped crystal. Now lead chloride dissolves in hot water. The chlorides of lead, silver and mercurous, that is Hg1 state and sulfates of barium, lead and calcium are also prepared using this method. Next is your calcium carbonate preparation. This is prepared by adding sodium carbonate solution to a hot solution of calcium chloride. Sodium carbonate solution to the hot solution of calcium chloride in a beaker till the former is in excess. That is sodium carbonate is in excess. You will get the precipitate of calcium carbonate and sodium chloride. Now the white precipitate is formed by the interchange of the ions. Here also there is the interchange of the ions, you can see. So that's why it is called double decomposition or double displacement. So the white precipitate here formed of calcium carbonate by the interchange of radicals. Now it is filtered, washed with cold water for several times and then collected. The washed precipitate is dried to obtain the amorphous powder of calcium carbonate. The carbonates of all the metals except sodium, potassium and ammonium are prepared by the above method. Then preparation of sodium bicarbonate. Now sodium bicarbonate is an acid salt. You can see in the formula it is NaHCO3, that is it is an acid salt. This is prepared by passing carbon dioxide gas into a cold solution of sodium carbonate. You can see sodium carbonate solution is kept in the ice. Dissolve nearly 5 grams of anhydrous sodium carbonate in about 25 cc of distilled water. Cool the solution by keeping the solution in the freezing mixture or ice. If you say freezing mixture, you can add ice and salt also. Salt will not allow ice to melt faster. So keep this in the mixture. Then pass carbon dioxide gas. The gas is coming here. Extra gas will go out through this outlet. The crystals of sodium bicarbonate will precipitate out. This black color is the sodium bicarbonate crystal precipitate. Filter the crystal, dry it in folds of filter paper. Now this sodium hydrogen carbonate or sodium bicarbonate is used as health salts. Health salts are the mixture of dry citric acid or tartaric acid and sodium hydrogen carbonate. On adding water, acid reacts with sodium bicarbonate to liberate carbon dioxide, which forms an effervescence ring and releases the gas pressure in the stomach. So you have to remember the health salts is very important. There are several questions comes at times. Now come to this neutralization process. Neutralization is also a double decomposition process. Here it is the process by which hydrogen ions of an acid react completely with the hydroxyl ions of a base to give salt and water only. Now this only is very important word. If you miss this only, your definition is incorrect. That we have discussed in the previous videos also. Now this is the example of a given. Base plus acid gives you salt plus water. Now you break this. Sodium ion, hydroxyl ion, hydrogen ion, chloride ion. So what you get? Sodium ion, chloride ion and water. Now sodium and chloride ion are present in the reactants as well as in the principal product. Principal product is your main product, that is salt. So you cancel out the ions present in the reactants as well as in one of the product. We get the following equation, that is H plus plus OH minus, you get water. Now this is the equilibrium sign or the reversible sign also. So this is very important and you know about this. Similarly, if you react potassium hydroxide with H2SO4, you will get potassium sulfate and water. So if you want to show this, that this is OH plus H plus OH minus and H plus gives you water. This is shown this way. Now this is 2K plus, this is 2OH minus. H2SO4 means 2H plus, SO4 2 minus. Here it is 2K plus, then it is SO4 2 minus plus water. Now why this is cut? Because to show that this gives you H2O. This is the process of filtration. This is the process showing of filtration. This is the conical flask. This is called burette. In this conical flask, this is the analyte it is called. You can take, generally you can take sodium hydroxide. Generally bases are taken over here in this conical flask. You can take acid also, and here this is called titrant. Now if the analyte, that is whatever you will be going for analysis, kept in conical flask with the any indicator, it is called analyte. Now here if you take sodium hydroxide, indicator if you give phenolphthalein, then it will give you a pink color. Here this titrant is maybe any acid. Let's say you take dilute sulfuric acid. Okay, so now you can do this neutralization of caustic soda with dilute sulfuric acid. Now this is what is heat of neutralization. It is the amount of heat liberated when 1 gram equivalent of an acid or base is completely neutralized. You just learn this term 1 gram equivalent because it's beyond the scope of your syllabus to understand what is 1 gram equivalent. Currently you just learn this word 1 gram equivalent. Now discuss little bit about this one, titration. This is the neutralization you can do. Here in the conical flask you can take caustic soda. Here in the burette titrant you can take the dilute sulfuric acid. So you will get sodium sulfate and water. This method is useful for the preparation of soluble salts of sodium, potassium and ammonia. Now here, to determine the neutralization reaction completion, whether the neutralization process is completed or not, this process, which is called titration, is done. Now come to the preparation of sodium sulfate. How to do? See, here again the titration process is shown over here. Take 25 cc of sodium hydroxide solution, a drop of indicator. Here it is shown litmus. You can take litmus also, you can take phenolphthalein also. If you take phenolphthalein, the solution will turn pink, and base will be, if you take blue litmus, it will turn red. The solution, or if you take blue litmus, it will turn red. The solution will be, if you take phenolphthalein, it will be pink, and now litmus, again it is red. Now the burette is filled with dilute sulfuric acid, and the reading on the burette should be noted 0. If you see the previous one, here you have, once the scale is measured, scale is there. Here 0 is here on the top, and here it can be 50 or 100, whatever is the burette size, 50 or 100 cc or ml. Now 0 is, you have to fill the burette, and you have to see this mark. You can see where the burette is written, this mark will be 0. So you have to see the reading, it should be 0. Now acid is run in drops into the conical flask where the alkali is kept till the last drop of the acid turns the solution colorless. This is known as end point. So this is very important that you should take some indicator which will give the color of this solution kept in the conical flask. That's why better to take phenolphthalein. You can take litmus also, no issues about it. Now again you come back, see this, means whatever acid you have added to make this solution colorless, that much acid has been used up, and this meniscus from 0 to come to certain value. So you note this value, how much acid has been added to this. Okay, so you will find, so let's say this is 0 and this is 15. So the amount of acid added is 15. Now acid and the alkali are now mixed in an evaporating basin. Taken, repeat without indicator. Now keep it over here. The resulting solution contains sodium sulfate and water. Okay, because the complete neutralization had been done. Now if you evaporate this solution, we will be getting the crystals of Na2SO4 10H2O, decahydrate. This is the reaction. Once you will evaporate it, you will be getting the 10 molecules of water gets associated with 1 molecule of sodium sulfate. Now in place of sodium hydroxide, here in place of sodium hydroxide, you can take sodium carbonate in this reaction. Now there methyl orange can be used as indicator. Sodium hydroxide and sulfuric acid are both soluble, and excess of either of them cannot be removed by filtration. So it is necessary to find out a small scale the ratio of the solutions of the two reactants required for complete neutralization before preparation. If you want to prepare sodium bisulfate, which is again the acid salt, you add same volume of sulfuric acid once again to the product formed in preparing the normal salt. The same reaction you have done several times. Crystals of sodium hydrogen sulfate is obtained from the resulting solution. The addition of twice the normal amount of acid will give you the formation of acid salt that you had already done. This is the end of the chapter acid base salt. Thank you so much.